In this video, I want to guide you through a couple examples of finding the equation for the inverse of a function. So our first example is going to be find f inverse if f of x equals the cube root of x minus 1 plus 5. So that's the problem I'm going to guide you through here. So the important thing to know here is the relationship between f and f inverse. Now the first thing I want you to understand is the answer to this type of problem should look like f inverse of x equals and then some formula. Okay, so that's what we're working towards. So how do we get started? Well, the first thing I would do is take this equation here and rewrite it as y equals, and then copy the right side. The reason I like to do that is because the relationship between a function and its inverse are that the input and the output switch. In other words, your next step here is going to switch your x's and y's. So every x turns into a y, every y turns into an x, okay? So write that step. And now once you've done that, your objective is to solve for the new y. And just some tips there, you're going to have to start dismantling basically the right side of this equation to get the new y by itself. So you have to know how to undo certain operations. The trickiest operation that when you get to it is how do you undo a cube root. So pause the video and think about that for a moment, how to undo a cube root, and then come back to see if you're right. So when you get to the step where you have to undo the cube root, you undo a cube root by cubing it. And of course, don't forget, when you cube it, you have to cube both sides of the equation. Now cubing, meaning raising to the third power, is not the first thing that you'll do to this equation because you've got this plus 5. So you have to get rid of the plus 5 first, and then you can cube to get rid of the cube root. Okay, so you've got all the tools you need. Go ahead and pause the video and see if you can solve for this new y, which should be in place of the old x. Okay, so you should have an answer. You should have the new y solved for. And the last step you're going to do is this new y represents f inverse of x. So you can rewrite this as f inverse of x equals, and then copy your formula. Pause the video, write that down, and then come back to see if you got the right answer. So your final answer should be f inverse of x equals the quantity x minus 5 cubed plus 1. And that's perfectly acceptable. Now, if you're asking, well, what about the cube? If you wanted to do the x minus 5 cubed, if you wanted to, I don't know why anybody would want to, unless they just enjoy this a lot, which I kind of do, you would take x minus 5 times itself 3 times. And you would multiply the first two binomials together, get the result, and then multiply that by that new trinomial by the x minus 5 binomial to finish, and then add your 1 to the end. But I like this answer even better. Okay, let's walk through the next example. The next problem is to find the inverse. I'm using slightly different language here. Find the inverse of the function g of x equals, it's going to be a rational function, it's going to be a fraction. So g of x equals x minus 3 over 2x plus 5. So the goal here again is to, our final answer should be g inverse of x equals some formula. Okay? So again, the first thing I'm going to do is write g of x as y, and then copy the right side. The reason we do that is so that I've got y's and x's only, and because I'm doing inverse, now x becomes y and y becomes x. So every place there's a y, change it to an x. Every place there's an x, change it to a y. And you'll get a new equation, x equals some fraction. Pause the video if you're not caught up, and then come back. Once you've got the x's and y's switched, you're dealing with inverse. So the new y represents g inverse. So what we want to do is solve for the new y. Now again, at this point you've got a fraction, right? You've got stuff on top, stuff on bottom of this fraction. So the first thing I would do, you're going to have a y on top and a y on bottom. I'd multiply both sides by the denominator so that your next step looks something like this, where the denominator's been canceled and all you're left with is the numerator. Okay? So you have no more fraction, that's good. The problem is you've got a y somewhere in this set of parentheses and you've got a y somewhere on the right side. So you've got y in multiple places and you're trying to solve for y. So to get the y over here that's in the parentheses, to get it out, distribute your x to everything in the parentheses. So now you've just got a standard equation with x's and y's floating around. No parentheses, no fractions. Now what you want to do is you've got a y on the left and you've got y on the right. So every term with a y, since you're trying to solve for y, you want to get your y terms isolated on one side. Okay? So you can get all your y terms on the left and everything else on the right, or all your y terms on the right and everything else on the left. So now at this point, you're going to have, let's say you got your y's on the left, and on the right you have no y's. So now what you're going to do, because you've got multiple y's on the left, is factor out the common y. So whether your y's are on the left or the right, go to that side and factor out the common y so that you get something like this. Y times the set of parentheses equals something without a y. And finally, now that you've got the multiple y's from this step down to a single y, you just divide both sides by whatever's in the parentheses here. And you'll end up with y equals some fraction. Okay? The last part is to rewrite y, because this new y, remember, represents g inverse of x. So rewrite that as a function, and the fraction here is your final answer. So pause the video, rewind if you need to, and go back and get all this figured out. And when you're ready, come back and I'll show you the right answer. Now if you did everything right, your answer should be equivalent to 5x plus 3 over 1 minus 2x. Some other ways you could write that is, depending on how you did it, you could have a negative in the front with a 2x minus 1 on bottom and a 5x plus 3 on top. And maybe there are some other ways, depending on how you worked out the problem, you'll get something else that is equivalent. So any of these are okay. Hope you did well, and I hope this helped. This second example is a tough one because you've got, the reason you know it's going to be tough is because you've got x in two places. So when those turn into y's, you're going to have y in two places. So you go through all this hard work to get all the y's together and then factor out the common y.